Hi, it's Jan Beta, and I have a little problem with my trusty old ZD-915 desoldering station. This is my ZD-915 desoldering station, or ZD-915, whatever you want to call it, depending on where you live. Mine is Additronic branded. There's also a lot of other brands that sell basically the same station. It is relatively inexpensive for a desoldering station. It has some issues, especially with the gun clogging up, but this has really served me well for all these years. I made a video about it when I got it and highly recommended it, and I still would recommend this exact desoldering station. But recently it has developed another problem that many people who use similar stations have reported, and that's this. You can probably hear the fan noise there. It got really loud recently, and I want to do something about that. So let's take this apart and have a look at what we can do. I think I should give this a bit of a wipe first, because I basically never ever cleaned this properly. So this just clips on here. As I said, this has some problems in regular use. You have to clean the gun quite frequently. The guns also break. I think I'm on my third gun. You can easily get replacements for those, thankfully. They're not super expensive. But the fan noise is pretty annoying. And there are some nice mods that I want to do that are optional, basically. You could just replace the fan. That's probably the fan that got loud, but let's have a look. There's screws on top here and screws around the bottom, and then you can take this whole thing off. So let's remove these. And yeah, there's a lot of modifications you can do to this to make it more useful. There are videos from other YouTubers who modded this, and after my fan started making some noise, which is a super common problem with these, we are going to take a look at why that happens in a second. I watched a video from Mark from the Retro channel, which I highly recommend, about doing some mods with a better power supply to the air pump. And I found a German site that has some more mods. Some of them I want to do. So this just lifts out, and it does look relatively clean from the inside, which is kind of surprising to me. So there's not much to this, as you can probably tell. This is the air pump for the suction. The motor is on top here. This is our little fan. This is actually the part that works really well, the pump section. This is the original power supply, and then there's this mystery black box that is bringing down the 18 volts, I believe, that the power supply provides to around 12 volts for the motor and the fan. And we are going to remove that and remove the fan. And I'm probably going to remove the RF shield on the power supply here for the most part to have better airflow. First of all, let's replace the fan, because that is really nasty. I'm going to do some more stuff to this, of course, but the thing that makes me open this up is the fan, which is clearly not working as expected anymore. This also is pretty bad. There's very little airflow naturally through these small holes. We're going to cut it out and put a proper fan grill on there for the new fan that I bought, which is a Sunon or Sunon good quality fan that we're just going to mount here instead of the other fan. And I think what I also want to do now is to basically remove all the components from this casing, just to have better access to this rear plate, which is a part of this. This is an L-shaped construction here. This part is plastic, this is all metal, and the components are screwed into this, basically. Just removing lots of screws. All of the screws. These are some long screws in there. And also our mystery black box is going to be replaced, but we're going to talk about that in a second. And this is a 24 volts fan, which is actually appropriate. So it's not running on a too high voltage in this case. Some of these have 12 volt fans, as I've seen in other videos, but this ran at the correct voltage. I'm just going to remove the other parts here so we can cut this out a bit. So I think now it's pretty safe to work on this and clean it up. So trying with a 5mm drill bit. Yeah, this should do. I'm just going to go all the way around there and drill this thing out and get rid of the debris later on. And of course, I need to smooth this slightly with a file. Let me take a couple of seconds to thank the sponsor for this video, PCBWay, my favorite manufacturer of prototype PCBs of all kinds. And if you've ever used a desoldering station, chances are that you have worked on circuit boards. And if you want to make your own, you can send your files to PCBWay.com and they are going to produce them for you. And they can even populate them and do all kinds of other stuff like CNC machining, 3D printing, sheet metal fabrication, you name it. I highly recommend checking them out. The link is in the video description. Back to our ZD-915 mods. So this is now a death trap kind of construction here. I'm going to smooth it out with a rounded file here, just to prevent this from being too much of a saw edge. I think that's good enough for me. No sharp edges anymore. And we are going to remove the dust with a vacuum cleaner and then take a look at putting the new fan in, which is the exact same form factor as the old fan, but a 12 volt fan instead of a 24 volts DC fan. And I think at this point I can probably mount the new fan already. Something like this. Let's put one grill on here. This is just an assortment of cheap 50mm fan grills. And that should go on here, like so. Yeah, that's probably going to work. So reusing the original screws here. Probably not going to screw this down fully yet because I want to do a lot of other stuff to this. That actually looks quite decent. New fan in place, but not fully screwed down yet. Only 2 screws in there. And we need a proper voltage supply for this fan, which is going to be 12 volts instead of 18 volts, I think, that the other fan got. And that's why we need to look at this box. So this box is what provides the 12 volts or whatever voltage the fan is to the fan, and also the 12 volts for the pump. And this is very, very shoddy, as we're going to see once I get this opened, because it's not a proper step-down converter or something that you would expect. It's just a bunch of resistors. There we go. That's all that is in this. 2 5 watts 1 ohm resistors wired in parallel, I think. And these are just going to bring the voltage down for the fan and the pump. And this is of course not very stable. That means once you actuate the pump, which is not running all the time, but actuated by the little trigger on the gun, the voltage for the fan is going to go down and the fan is going to slow down, which is also audible when you use the station. It is some kind of DC to DC converter, but not a proper one. So I got a better one, I hope, which is this here. This is a very cheap DC to DC buck converter. So a switching converter, DC to DC converter that takes the input voltage and steps it down to whatever you want. I think this is preset to 12 volts. And we are going to use that as our new replacement DC to DC converter, which this clearly isn't. This is a proper DC to DC converter. So this is going to run more stable and provide the correct voltage for the fan. It also has a fan connector here, or at least some solder pads for connecting a fan, which we are going to use to connect our fan. But first of all, we need an input, that is the wires coming from our power supply, and the output is going to go to our pump, and then the fan is going to connect here. There's some little modifications we have to make to this. This was just a couple of euros, so the soldering looks super shoddy. We're going to clean that up a bit. And yeah, this component, I think a resistor, is also not really sitting on the pad. I think I'm going to do some work on this and clean it up properly. And then we have to close a little solder jumper here. For the fan voltage, there's actually a little jumper that says voltage in and voltage out. And we have to set that to our output voltage, I think. Otherwise, the input voltage is going to our fan connector here. So you can just use that for connecting a fan, which is super handy. Yeah, this looks much more trustworthy. But this is now in there in a more proper way. We're going to have to close our solder jumper, of course. And we want this on the pad that says V out. So these two have to be connected with a blob of solder. There we go. So now we should have the output voltage of this buck converter on our fan contacts there. Another problem with these is that there's only one phase switched by this power button here. Although the switch actually has contacts for two phases. But you can see that this brown wire here is just going to the switch and switched to the power supply in this can. And the other wire is just coming directly from our power socket here. And we are going to switch that too. So this wire, the red wire, is going to be connected to our power switch. And then we are going to connect the switched part of this to the other end of the wire that is not switched yet. But first we could potentially take this apart. Also, for better airflow, we can remove most of the shielding on this, I think. This has a ground connection, which we're going to have to remove. Just have to remember to put that back, because that is pretty crucial. I think we can remove this whole shiny part and just leave this aluminum bracket here. Should come out. So we have to take this apart a bit further. The bottom plate here has to come off. Oh yeah, that's literally just a plate. And yeah, there's another screw there that holds our shiny part in place. Yeah, and then this just lifts out, I guess. Yep. There we go. So this is just held in with two screws, one on top and one on the bottom there. And after removing this bottom plate, you can access that. It claims to have an output rating of 18 volts, 12 amps. I'm not sure if this can provide 12 amps, but it looks beefy enough to power something like this. And it also doesn't look that bad. The capacitors, of course, are super cheap brand, but good enough, I guess. And there are even little rubber grommets to feed the wires through. Of course, all of this voids the warranty instantly, and also this would not be safe to operate in any production environment. This is just my personal responsibility for using this in my personal space here. Not recommended if you are using this in any kind of production environment or in professional way, which you probably won't because this is a hobbyist thing. I don't think this is even used that often by professionals. So yeah. So I'm going to cut it here and remove it from this. Maybe it's just a spade connector. I think this might be soldered. Okay, that's just the heat shrink and it's just soldered. It just looks like a spade connector. Yeah, spade connectors are expensive. So we're going to cut this and desolder it from here and solder this end, which goes to our power supply, to the switched on side of the switch. And then I'm going to run a new cable from here to the other end of the switch. So that's desoldered. So this is getting some red heat shrink quite appropriately. And I'm going to solder that to this second contact on the switch here. And just as the reminder, I have no proper education in this field, so I clearly don't know what I'm doing. So don't trust anything I say in this video, especially the mods concerning the power input. So I got that on there, soldered. Now I'm shrinking the heat shrink. And I'm going to run a wire from the other phase of the power input to the other terminal here on the switch. And I'm using a blue wire that I salvaged from an old extension cord, which should be wide enough diameter. Just putting some heat shrink tubing over the contacts there and running it from the mains input to the other end of the switch here that we didn't populate yet. So now we have a blue wire from our switch to our mains outlet, and the red wire is going to the power supply then after the switch. So this is now switching both phases ideally. And the brown wire and the blue wire going to the switch in the off position, being switched to the red wires. So both phases in the on position, and these are going to the power supply. Yeah, we can put the power supply back and connect it back up and see if our station still works at this point. So just putting the bottom plate back on here, on our power supply, and I'm leaving out the rest of the metal parts there. But I am going to put the ground connection back on, of course. I am going to screw the power supply back in there because that also has a screw with the washer on it, which is the ground connection to the case actually. So quick function test with no fan and no buck converter and no pump connected, but it should still power up hopefully. Yep, and it beeps, and we don't have the temperature sensor reading there, of course, because there's nothing connected here. So our switching seems to work. Yeah, let's see where our voltages come out here. I think this is the one coming from the power supply that went to our little shoddy DC to DC converter board, and we're going to connect that to our new board on the input. After determining if the black or the white wire is the positive, there should be 18 volts on there. And then we are going to connect the output here to our pump with some modifications that we are going to have to do to the pump itself as well. So just set up my multimeter here to DC. This is 18 volts roughly, and it's instantly turning off here. We don't have anything connected here. So it's going into fail-safe mode probably. Yeah, but we had 18 volts and the black wire is actually the positive, it seems. So we are going to connect our little buck converter, the input of that, with the black wire going to the positive terminal. And then we're going to see what the output says, I guess. Usually the black wire is always the negative, but you never know. Let's power it on again. And our little LED lights up, yay! And we have 10 volts briefly. Yeah, we have 10 volts on here. So far so good. This thing seems to do what it's supposed to do, at least for now. So I got myself a smaller screwdriver to set this to the correct output voltage, which should be roughly 12 volts. This should now output 10 volts, yes. And we are going to set it up for 12 volts with the little adjustment screw that's on there. Good enough. So this works. We have a stable 12 volt output from this little DC to DC step down converter. That's good. So we can power our fan with this and our pump. We have to make some adjustments to the pump before we can do that, because we don't want this to be damaged by the voltages returned from the pump. Before we can connect the motor, we are going to put a flyback diode on here that is to prevent current from the motor when it stops going back to our power supply circuit. This is a huge inductive load basically, and a flyback diode prevents the unloading of this to the circuit via backwards voltage. So we are going to put a 1N5408 diode in here with the cathode of the diode facing the positive side, which is marked by a little plus on the motor here. Just going to solder it over here. This little contraption here in the middle is two ceramic capacitors actually, to also block noise from the motor. Yeah, I'm going to have to get this heat shrink tubing off here and desolder these wires, I think, and then put new heat shrink tubing over there and the diode. And I'm probably going to insulate the legs of the diode with more heat shrink tubing even. So yeah, just to prevent our power supply, our little DC to DC converter from being damaged. I guess this thing here didn't care too much about backwards voltage because it's just resistors, but our DC to DC converter is going to potentially be damaged by the voltage returning from the motor when it stops. So we are going to prevent that. Desoldering these two wires. I already marked the positive wire and I marked it on the other side too. These have different markings on them, the wires. One has a little dot going through it and one a little stripe. And some heat shrink tubing over the contacts is going to prevent this from shorting out with anything. Okay, so we have our flyback diode here connected and our power input, and our capacitors we're just going to leave in place here. So we can connect the other end to our power supply and actually test this thing. And I'm probably going to end up soldering these directly to our DC to DC converter after determining everything works as expected. But for now I'm going to use the little screw terminals that are on here just for testing. I'm also going to connect the fan, I guess. Just going to solder it straight to the board. And I am going to remove that again and shorten the wires a bit after we determine this works. This is just for testing. It's all going to be nice and clean in the end, hopefully. So now we can, in theory, test operation. Also connected the gun to test the pump operation. Oh, the fan is super quiet. And the pump is operating. Okay, nice. But it's not heating up. Oh, there we go. Took a while. But this takes a while. Yeah, Seems to work nicely. And the pump, of course, is not screwed down, so it's a bit louder than normal. This seems to do what it's supposed to do. And the fan is so much quieter now. And it's actually blowing air out of the case with quite some nice airflow. Yeah, much better than before, much quicker action. So let's let this cool off and unplug it. And then we can think about mounting it all permanently. Yeah, after determining that this works, I'm just going to take these wires off here again. And I think I want to permanently solder them to the board. You could, of course, put some connectors on there. I guess I'm just going to solder them because this is constantly going to vibrate. And then I'm going to mount this somewhere like here, I guess, in the back of the case with some standoffs. It has some pre-drilled holes here. And I think I want to add some bits of hot glue to the capacitors here because of the vibration to make it more stable, basically. We are going to take everything out here to drill some holes in the back after I have determined where this is going to go. Going to use this as a template to mark my hole positions here. Then some standoffs on here, and we are going to screw it to the back of the casing. So I removed the little screw terminals with some solder braid because I don't have a working desoldering station at this point. And we're going to take everything out of the enclosure again before drilling these holes and clean it up. Put the wires onto our little contraption and mount it with some standoffs. So I managed to get it in with these nylon screws here and some nylon standoffs that I had from some other project, I believe. Hopefully that's going to prevent the vibration a bit because it's more elastic than metal, but it's also going to insulate the circuit from the casing completely. Now the only question is if we can get our power supply in here with the wires in place. Yeah, it just fits. Yeah, putting everything back together, I guess, at this point. Just going to try to reassemble this neatly and put some hot glue on some of the capacitors. I think also in this power supply, actually. So these are all going to vibrate a bit, so we're just going to fix them a bit better. It's not strictly necessary and it looks a bit messy, but just to prevent this from vibrating too much when the pump goes off. And I'm also going to have to screw in my fan completely now. And then I'm going to put some nice cable ties in and things like that. Okay, final test run before closing this all up. Fingers crossed this still works at this point. Let's see. It's super silent. Heating up slowly. And the fan actually is much more silent than the old one. That's super cool. And the suction seems to be more direct, so faster acting, which is also a huge plus. Let's see if we can actually desolder something. Maybe we can desolder these large resistors here. Yeah, and the suction is a lot more stable now. I didn't even clean this up properly before the mods here. And this works beautifully still. That's nice. Yeah, still works. Nice. So I'm going to put some cable ties in and route the wires properly. Probably give the voltages a check. I also deliberately placed this in a way so I can still somewhat reach our adjustment screw for the voltage. I'm going to check the voltage on the pump, but first of all I'm going to put some cable ties in here and clean it up a bit. I am super pleased with how this turned out, actually. Great modification, or some modifications actually. There's a plethora of other options. One of them is that actually the pump supply voltage is traveling to the switch in the gun. And yeah, there's a long way of pretty thin wire going through there. That is not the best. You can put a relay in here to make that happen directly. The switching happen directly in here with shorter wires. Maybe I'm going to do that eventually, but for now, this seems to work nicely. So I have my multimeter hooked up to the diode legs on the pump, so we should see the voltage going through the pump when I actuate it. That's 11 volts. So we can raise that a bit to around 12 volts, I guess. Turbocharging. So I think I'm going to settle for something like this, 12.5. Just adjusted my little screw there a bit. Of course, the voltages are going to vary a bit under load, like this. And our fan is going to take 12.5 volts, fine, I think. Maybe we can even go a tiny bit higher. I've heard people running this at 13 volts. And it's already a huge increase. $12.8, I'm going to leave it at that. Sounds a bit faster than what we had before. And the motor is probably going to take it fine. So is the fan. So that's the voltage I'm going to settle for. Kind of a little turbo charge here. I think that's it. We can close it up. After letting the gun cool down for a bit. I should have routed these wires for the mains on the other side of the power supply there, I think, but it's going to fit fine. Just would have been neater to have them separate from the case a bit more. This bracket that the power supply sits in is actually deburred quite nicely, so I'm not risking ripping these wires in operation, I guess. And it's going to close up quite nicely still. So let's put all the screws back in and put it back in operation. And of course I'm going to report in case my slightly increased voltage doesn't work as intended. But I've read in the forums that several people have done a similar voltage or even higher, like 13 volts. And that worked fine for those people. So I suppose, hopefully, this is going to work for me as well. And hopefully keep working for some time, because this is really a daily driver. That's why I was so annoyed by the noisy fan. It's much more silent and much more stable now. You can put a piece of electrical tape on this here to make it a bit more stable. I think that's a reasonable thing to do. I'm just going to find some electrical tape. That's the final mod. At least for today. Yeah, that's much better. Okay, I'm going to put it back where it belongs in the lab. And there it is. Much quieter now. And the suction sounds faster, so hopefully this is going to work a bit better even. Oh yeah, the suction feels a bit better actually. And there's no slowdown of the fan anymore. At least it still works as good as before, if not better. Yeah, this is glued down, so I can't really take it out. Yeah, that's it for today. I hope this was informative and maybe inspired you to do some similar mods to your desoldering station. These things are really nice for the money that they cost. And yeah, as I said, this served me well for well over 8 years now, and it started breaking down just a couple of weeks ago, basically. I hope this is going to serve me well for another 8 years. I'm not quite sure. This is cheap stuff, but we're going to see. I'm going to report back on my voltage modification there, and yeah, hopefully it lasts a while. Thank you so much for watching. Thanks for your thumbs and your comments and your subscriptions. Special thanks to everybody who supports me on Patreon or on Ko-fi or on the YouTube channel memberships page. Very much appreciated. And these projects wouldn't be happening without you. I'm Jan Beta. Thanks for watching. See you next time. Bye.